This lesson is on the parabola. Parabolas are the shapes made by quadratic functions. They're also part of a conic section. There's specifically the conic section where the line that represents the average distance between 2 points, two opposite points in a parabola, is parallel to the line furthest from it on the conic section. So for quadratics, we would often represent a quadratic function as y equals a times x minus b squared plus c. If you move things around a little bit, you'll notice that this is the same thing as 1 over a times y minus c equals x minus b squared. I can also reverse this order. And now this is called, well, this is almost called the standard form. We have to do one more thing to make it the standard form. That is the standard form. This is very special to parabolas, at least parabolas that open up or down. We're going to go over what all these letters mean now. I can draw my axes for a graph here. And now, let me draw a parabola. The parabola has a special point called a focus and a special line called the directrix. Each parabola has only one focus and one directrix specific to that parabola. And here's what's special about it. Any point on this parabola, let's say this one for example, the distance from it to the focus is equal to the distance from it to the directrix if we go straight down. This is true everywhere. If I go directly down, the distance is the same. If I go slightly over, the distance is the same. This is what's special about the parabola, or at least one of the many things that's special about it. The vertex of this parabola is at a point h, k. That may immediately explain two of the letters seen in the standard form equation shown previously. Also, this distance here is p, and so is that. Also, parabolas don't really care what orientation you use. So instead, I can draw this sideways. So here, I've drawn my axes, and I've picked a directrix, the y-axis, and a focus, that point that's dark there, and I can go ahead and draw what this parabola should look like by just picking points that are of equal distance from both the directrix and the focus. By connecting these dots that I've made, I'm left with a parabola. Again, the vertex is still h, k, and these distances are still p. It can be seen here that if you have a parabola that opens to the left or right, the focus is going to be at the point h plus p, k. And as for the directrix, well, it's not really a point, it's an entire line. So we just give it an x equals or a y equals that best describes it. And in this case, because our parabola opens left or right, that means we're going to have an x equals. Just like how for the focus we added onto the x coordinate because it was shifted down on the x-axis, our directrix is going to have an x coordinate and only an x coordinate. Our directrix is x equals h minus p.